Welcome to Independent Events Without Two-Way Tables. Just to recap what we did last time, we talked about how independent events is when the probability of one event happening does not affect the probability of another event happening. From the last video, these were the two formulas that we used. We have the conditional formula, where what comes first has to be by itself. And we have the multiplication formula. You can also see this as the probability of A and B with the symbol for the intersection. So the first one is called the conditional rule. The other one we call the multiplication rule for independence. So if these are equal, then we know that they are independent. If the left does not equal the right, then we know that they are dependent, or in other words, not independent. So in this video, we're going to talk about word problems without a two-way table, and you're going to have to figure out, do you use the top formula or do you use the bottom formula? So in our first example, we have given the events A and B such that the probability of A is 0.6, the probability of B is 0.5, and we have the probability of A union B. Remember that this symbol represents OR, is 0.8. Determine whether A and B are independent or dependent. So we have to use one of those two formulas from before. The question is, which rule should we use? The one with P of A and B, or the one with P of A given B? Now, because they don't actually give us conditional probability here, I would just, cross it out. Technically, you can do the problem with the conditional rule. It's just an extra amount of steps. Let's do it with this, because if you remember, they gave us or probability instead of and probability. So please be careful about that. You have to know the difference between the and or symbols. Now what we want to do is use this formula. P of A and B is equal to the probability of A times the probability of B. Now, we have the probability of A, that is 0.6. We have the probability of B happening, which is 0.5. What we do not have is the probability of A and B. We can't check to see if they're independent if we don't have the left side of the formula. So instead, you need to think about what can give you the probability of and that's when the OR probability comes in handy, because OR probability, there's a formula for that, which is the probability of A or B, the union, is equal to the probability of A plus the probability of B minus the probability of A and B. We have the OR probability is 0.8. The probability of A is 0.6. Probability of B is 0.5. Minus, we have no idea what the and probability is. We're trying to figure that out, so we're going to put an X. From there, you're going to combine like terms, and we're going to get 0.8 is equal to 1.1 minus X. If you bring the 1.1 over to the other side, you end up with negative 0.3 equals negative X. Keep in mind your answer for probability cannot be negative. There's never a negative % chance of something happening. So you have to get rid of the negative. You can divide or multiply by a -1, however you want to do it, and you get that X is equal to 0.3. Now remember, we said X was the probability of A and B. which is what we wanted. So I'm going to take this, now that we have the and probability, and I'm going to input it in my other formula to test to see if it is independent or not. So now we have this formula. If the left is equal to the right, then they're independent. So we have 0.3, and in the calculator, I'm going to do 0.6 times 0.5, and you're going to get 0.3. Because they're the same, we know that they are independent. And we're done. Let's try another example. According to a survey, the following information was determined. The probability that someone participates in an after-school activity is 0.4, or 40%. I'm going to write that down. Now, the probability that a randomly selected student who is a female participates in an after-school activity is 0.4, or 40%. Keep in mind that this is your condition. So they're giving us the probability of after school given they're female. They want to know, are being a female and participating in an after-school activity independent events? So you need to think, which formula are you going to use? The one where you have the probability of A and B is equal to 1 times the other? Or are you going to use the conditional probability rule where A given B is equal to the probability of A? Again, keep in mind that what comes before this condition or the slash is what has to be by itself. Now, it makes sense if you look at this. We're given conditional probability, so we should use the conditional probability formula. Our condition was, or rather the conditional probability was 0.4. Now, if you notice, after school came first, so this should be equal to after school by itself. And we have that the probability of being after school is 0.4. Because the probabilities are equivalent, we're going to say that they are independent. Now, this problem does ask you to explain your answer. For independent event questions, a really good explanation is because being a female does not change the probability of being in an after-school activity. So basically, your explanations should say, what is your condition? And you're going to use that condition and say, hey, being a female, our condition didn't change what we were originally testing, the probability of being in an after-school activity in this case. On the next one, and I'm just going to write out all the information as I go along with the problem. On a given school day, the probability that Nick oversleeps is 48%. So the probability of oversleeping is 0.48. The probability that he has a pop quiz is 25%. So the probability of a quiz is 0.25. Assuming these two events are independent, what is the probability that Nick oversleeps and has a pop quiz on the same day? So we're looking for a probability of oversleeping and, or you could put the intersection formula, intersection symbol. So oversleeping and pop quiz is equal to X. So because they told us that these two events are independent, you can use a independence formula. The question is which one? They didn't give you conditional probability, so I would avoid trying to use that one. Instead, I would use the multiplication one, the one that involves and probability, which is the probability of A and B is equal to the probability of one times the probability of the other. They gave us the probability of A to be 0.48. The probability of B is 0.25. Remember, if you did 0.25 times 0.48, it makes no difference because multiplication is commutative. And we have no idea what A and B is, so I'm going to put X. When you multiply these two together, you should be getting that X is equal to 0.12, which converts to 12%. In this problem, we have a fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers that the events D, that a customer uses the drive-thru, and F, that a customer orders French fries, are independent. The following data are given in a report. Given this information, P of F given D is what? So first of all, I want you to be really careful with these questions on the regions because here they said that the events are independent, which allows you to use independent formulas. However, I have seen these questions like this, but they don't say they're independent. So in that case, you can't use this formula. Now, because they're asking for a conditional probability, you can really use two formulas. You have the independent formula, which we know is P of A given B is equal to the probability of A, because what comes first has to be by itself. The other formula you can use is the probability of A given B is equal to the probability of A and B over just the probability of the denominator, not the denominator of the condition. So just keep in mind the difference between both of these. For independence, what comes first has to be by itself. For the basic conditional probability formula, what comes last has to be in the denominator. But the red one is specifically for independence. Now, it might be a little bit more confusing to figure out which one to use if we're talking about A and B, so I'm going to switch this to F and D. So the whole point of this problem is to try and trick you with which one you should be using. Now, notice how, look at what they gave you, right? Notice how they give you the probability of F. Now, in the question, F comes first. So they're giving you the probability of what comes first, and that matches with the independence formula because what comes first has to be by itself, right? They didn't give you the probability of D in order to use the other formula, so we have to stick with the independence one. In this case, we have that the probability of F given D is equal to the probability of F, which they said is 0.8. Fairly simple question if your formulas. And these are not on your reference tables. You have to remember them. So looking at this question, before even reading the actual question, the answer choices, I automatically know that either dependent or independent has to be in my answer because something is either independent or dependent. There is no third option. So one of them has to work. Anyway, going on to this question again. The probability that Gary and Jane have a child with blue eyes is 0.25. So probability of blue, 0.25, and the probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125, so that's and probability. Given in this information, the events blue eyes and blonde hair are what? So let's talk about what it means to be mutually exclusive. Mutually exclusive means that they cannot happen at the same time. The events occur separately. So if you think about it, in this problem, the child can have blue eyes and blonde hair at the same time. It even says that probability is 0.125. So because they both happen at the same time, you can cross this one off the list. Can't be that. So it has to either be 1 or 2, which means choice 3 and 4 are off the table. So because we're talking about independence, you have to use your independence formula. Not going to use conditional because they're not giving you conditional, they're giving you and. So try working with the probability of A and B is equal to the probability of one times the probability of the other. We have A and B is 0.125. The probability of A is 0.25 times the probability of B, which is 0.5. When you use your calculator, you should be getting that they are equal. And because they're equal, that means they are independent, which would be choice 2. Okay, last one. Suppose events A and B are independent, and the probability of A and B is 0.2. Which statement could be true? Now, the fact that they're saying independent and giving you the and probability should clue you in to look at the independence formula, the ones that have the probability of A and B is equal to the probability of A times the probability of B. Now, we know that the probability of A and B is 0.2. So we're looking for two values that multiply together to get 0.2. That means before I check 1 and 3, I should try 2 and 4. I'm not saying 1 and 3 are wrong, but I'm saying that this is my independence formula. I need A and B in order to use it, and choice 2 and 4 have A and B. So in the first one, 0.8 and 0.25. If I multiply those two values together, I get 0.2. So it works, and it has to be choice 2. Let's look at what would happen if you chose the other one. I have 0.2 is equal to blank times blank. And I have my two values, 0.15 times 0.05, well, if you were to multiply that together, you would get 0.2 is equal to 0.0075, which we know is not true. So I'm going to cross that out. The top one, choice 3, on the right, is wrong as well because what comes first has to be by itself in order to use the independence rule. So in this case, yeah, they're both equal, but this is the probability of B. We want the probability of A. So this should be the probability of A is equal to 0.2 in order for choice 3 to be correct. Now, the last one, or rather the first one, doesn't work either because if you use the OR probability formula, P of A or B is equal to the probability of one plus the probability of the other minus the probability of them both at the same time. The OR probability is 0.5 and is 0.4. B is 0.3. And we have that and is 0.2. So you might be thinking that, yeah, 0.5 is equal to 0.5, and that's all great because it works out. But the problem did say that they're independent. So if you actually use the independent test for this, right, we should be equaling, if you have the probability of A and B is equal to the probability of A times the probability of B. The probability of A and B is 0.2. The probability of A here is 0.4. The probability of B is 0.3. Now, if you put that in your calculator, 0.4 times 0.3 is 0.12. So this doesn't work because it means it's not independent. Yeah, it might work for the OR equation, but because it's not independent, which this problem said that they were, it doesn't work out overall. And that's why choice 1 is no good either. It has to be choice 2. Anyway, just keep in mind that when you're dealing with independent problems, anytime you see the word independent or independence or dependence in a question, use the formulas. And if it's not in a two-way table, you have to check and see, should I be using the multiplication rule? Did they give me and probability? Or should I be using the conditional rule? Did they give me a condition here? And that's all for this video.